Hello, today we are going to talk about the quotient, that means division, of powers. And this is very similar to the lesson we worked on yesterday, which was product of powers, multiplying powers with the same base. And yesterday when we learned it, we learned that when you have the same base, you add the exponents because we're just keeping track of all of that base. All right, so this is very similar. Now we're going to subtract their exponents. So when I have the same base, in this case it's the big 3, written as a fraction, a division problem, we are going to subtract the exponents. So 3 to the 7th divided by 3 to the 3rd, we subtract our exponents and we get 3 to the 4th. We can do the same thing symbolically, where essentially you write your base and subtract the exponents. Okay, a can't be 0 because we cannot divide by 0, so that's why this rule is here in the symbolic version. All right, let's take a look at what's really going on. And then what you'll hear me say is like bases subtract exponents. Again, this is in a division problem. All right, so how does this work? Well, let's say we have the problem x to the 5th divided by x squared. That is really, when we expand these, x times x times x times x, so 5x's divided by 2x's. All right, and if you recall, if we take x and divide it by x, we get 1, so they essentially cancel out. And I can do the same thing with this pair of x's. And what I'm left with now is 3x's in the numerator, and we can write that x times x times x is x to the 3rd. So that's why this rule works out. All right, so let's try a few. So this is example 3. You'll put this right in your notes. Okay, and it's going to look like this. So if we have maybe just numbers as a base, 4 to the 8th divided by 4 squared, they have the same base. I'm dividing them, so I'm going to subtract these exponents. That's going to give me 4 to the 6th power. All right. If at any time I'm moving too fast, you can just pause the video and get yourself caught up. Now, with a variable base, n to the 9th divided by n to the 4th, they have the same base, so that's good. I'm dividing them, so it's 9 minus 4, n to the 9 minus 4, which is n to the 5th. So these are two pretty basic examples. And then something a little more tricky. Let's say we have a couple of objects, I guess, in the numerator and denominator. We're going to match them up with like bases, and we're going to take care of each of these as we go. So I can say 2 to the 5th divided by 2 squared is 2 to the 3rd. 3 to the 5th divided by 3 to the 4th is 3, or 3 to the 1st power. And 5 squared divided by 5 is also 5 to the 1st power. There'll be 1 5 left when I make this division, 1 3 left, and 3 2's left. So this is how we'll write that. 2 to the 3rd, that's 5 minus 2. The 3's, all of them will cancel but 1, so that's just 3. You can write to the 1st power if you want to. And 5 squared divided by 5, again, just 1 5 will be left, so we write that. All right, let's move on. What I'd like you guys to do is pause this video and try these 6 problems. See how you do. All right, so we are going to go over them. Again, the 5's have the same base, 5 to the 7th over 5 to the 4th. So 4 5's are going to cancel the numerator. That's going to leave me with 3 left, so that's 5 to the 3rd. X to the 10th power divided by x to the 3rd. Again, 3 x's in the numerator are going to cancel out the 3 from the denominator, and that's going to give me x to the 7th. Now this one with the coefficients, if you recall from yesterday's lesson, when we were multiplying variable terms with coefficients, we multiplied the coefficients. And this time, because it's a division problem, we're going to divide them. So 12 divided by 2 is 6. And now I'm doing a like base, because the w's are the base. A like base, subtract exponents. And again, if you recall, when there's just one w here, that exponent's 1. So that's going to be 6. 12 divided by 2 is 6. W to the 4th. All right, back to a very similar example from the last slide. We got our 3's, our 5's, and our 7's all lined up, like bases. Subtract exponents because we're dividing. So 4 minus 2 is 2, so we're going to get 3 squared. 5 minus 1 is 1, or 2 minus 1 is 1, so we're going to get 5 to the 1st here. And again, the 7's, there's 5 here and 3 here. 3 are going to cancel out 3 up here. That's going to leave us with 7 squared in the top. So 3 squared times 5 times 7 squared. Same problem here. All but 2 of the 5s are going to cancel out. 2 of the 7s are going to cancel out, and 1 or 2 of the 8s are going to be canceled out. So it's going to be 5 squared times 7 squared times 8. 6 minus 4 is 2. 4 minus 2 is 2. 3 minus 2 is 1. And again, if you want to write the 1 for now, that's totally fine. Now we have the last example here. Negative 2 is our base. I have 5 in the numerator and 2 in the denominator, so 5 minus 2 is 3. 4 3s in the numerator, 1 3 in the denominator. 4 minus 1 is 3, so 3 to the third, and then 5 to the third. 7 minus 4 is 3. Right? And remember, when you have a negative base, you should put it in parentheses. It is very important. It's not a step you can skip. And if you put it in your calculator without parentheses, you're going to end up with issues too anytime that exponent is even. Well, we talked about that on Thursday and Friday last week. All right, let's take a look. Here is just a real-world problem. So Hawaii's total shoreline is about 2 to the 10th power miles long. New Hampshire shoreline is about 2 to the 7th miles long. About how many times longer is Hawaii's shoreline than New Hampshire? So what have we been doing in this lesson? We've been taking like bases, we've been dividing them. So we're going to set up our division problem. Whoops. We're going to set up our division problem, 2 to the 10th divided by, so let me do this really quick. 2 to the 10th divided by 2 to the 7th. And again, like bases, subtract exponents. 10 minus 7 is 3. So that's going to give us 2 to the third power. And because it's a real world problem and this number is not too hard to deal with, we're going to get the answer. 2 to the third is 8. So it's 8 times larger. 8 times larger than New Hampshire shoreline. Again, Hawaii's got all those little islands, so that all counts. It adds up quickly. All right. Now, I want to talk about common errors first. That's right. So what do you think a common mistake students make in both of these issues? So when we're product of powers, when we're multiplying to add the exponents, and quotient of powers when we're dividing to subtract the exponents. Some of the common mistakes kids make is they add or subtract exponents that do not have the same base. So maybe I have a 5. For example, I might have 5 squared over 3 to the first power. I can't subtract these exponents. All I could really do in this problem is write 25, because that's what 5 squared is, over 3. So we cannot subtract or multiply or add exponents when the bases are not the same. And then I got to erase that. There we go. And then the other common mistake is students who multiply or divide the exponents. So you're multiplying the like bases and you actually multiply the exponents, or you're dividing the bases and you think you should divide the exponents. So be wary of those two things. Again, only works if the bases are alike. So I hope this video helps, and I will see you guys next time.